Okay, so in this lesson we're going to be looking at how to graph inequalities on a coordinate plane. Now you might think that, well, haven't we already done this? Well, at the very beginning of the chapter we were graphing equations or inequalities with only one variable. And we had to do that on a number line because if it only has one variable, it's only one-dimensional. Where here we're going to be graphing inequalities in two variables. So that means it's going to be two-dimensional, meaning we need to have both axes here. Now there's going to be some similarities here to graphing regular equations. So in the past we've talked about equations in the form y equals mx plus b. Remember, if we're going to graph a situation in that case, you start by graphing your y-intercept where it crosses the y-axis, and you use your slope then to come up with another point on the line. Well, that same idea is going to apply here, even though it's in an inequality, except for with one minor, or actually major detail, is that's the type of line that we're going to use. When we graph an inequality, there's going to be times where we're going to graph it using a dashed line, and times where we graph it using a solid line. Now we use a dashed line anytime our inequality is going to be just less than or greater than. We use a solid line to indicate that it's going to be greater than or equal to or less than or equal to. And I'll explain why that is when we graph this one. So let's look at this first example here. It says y is greater than negative 1/2 x plus 2. So I start by graphing my y-intercept. The y-intercept is a positive 2. My slope is negative 1/2, meaning, remember, if your slope is negative, it means you go down. If it's positive, you go up. And we always go to the right, so I'm going to go down 1 unit and to the right 2. So I go down 1 and to the right 2. Now I want to make sure I have an accurate line here, so I'm going to come up with some more points. If I go backwards, I'm going to go the opposite for each of them. Instead of going down, I'm going to go up. Instead of going to the right, I go to the left. So I go up 1 to the left 2. Now you need to stop yourself. Before you connect these points, you need to determine whether we use a dashed line or a solid line. Now you can see from my notes up here that since it's going to be since it's greater than, we're going to use a dashed line. But let me explain why we use a dashed line. When we graph an inequality, we're graphing a region. Now, we're looking at a set of points here where we could put values in for x and y, and we want to figure out what set of points would I put in for x where my answer for y would be larger. Now, the points that are on the line, since its y is greater than these values for x, the points on the line are not going to be included because it's not equal to those values. It's going to be greater than those values but not equal to it. So to figure out whether we shade above or below the line, what we do is we pick a point not on the line. Like, let's say if I pick a point 0, 0. 0, 0 is not on the line. I want to see, is that point part of the solution? Would this make a true statement? If I put 0 in for y, is that going to be greater than negative 1/2 times 0 plus 2? Well, let's see. Negative 1/2 times 0 is 0. 0 plus 2 is 2. That is a false statement. So that means 0, 0 is not a solution. That means, so that implies that everything above my line here is what I'm going to shade in. Okay, so that's what you do in your assignment. You do a dashed line, and we would shade everything above the line. Let's try another one. So here, when we go to graph this one, our y-intercept, well, if you notice here, I forgot to give you a new equation. It's a problem with cutting and pasting when I made this worksheet. Okay, so we're going to do 2x plus 3 here, but let's make this greater than or equal to. So y is greater than or equal to 2x plus 3. This is when we're going to graph. Okay, so I start out with my y-intercept is 3. Now anytime you have a slope that's an integer, that means it's over 1. So I'm going to rise up 2 units over 1. Well, I want to have a better idea. I know my line is going to increase from left to right. So if I go backwards, I have to go down 2, but to the left 1. Now this is greater than or equal to these values for x, so I'm going to use a solid line, because that means that the points on the line are going to be included. Now I need to figure out, well, do I shade above or below the line? Pick a point not on the line. Let's say if I pick 0. 0, 0. If I put 0 in for y, does this make a true statement? Well, 0 is greater than or equal to 2 times 0 is 0. 0 plus 3 is 3. 0 is not greater than or equal to 3, so this is a false statement. So 0, 0 is not included. So that means we shade the region that does not include 0, 0. Now, people all the time look for shortcuts, and they say, well, wait a minute, here it was greater than, and we shaded above the line. Here it was greater than or equal to, and I shaded above the line. So does it always mean that if it's greater than, I always shade above the line? If it's less than, it's below the line? That is not always the case, so please don't get in the habit of doing that. It does work sometimes. And if you want to see if you can figure out the trick to that, you can do that. But otherwise, I always assume that you always have to pick a point, like we've done here, to see if that point is on the line. If it makes a true statement, then that region is included. If it makes a false statement, that region is not included. So let's look at some other examples here. These are in standard form. Remember, when a graph is in standard form, the best way to graph that, or one of the best ways to graph that, is to find the X and Y intercepts. So if I find the X-intercept here, I cover up the Y. So to find the X-intercept, I divide both sides by 3, which gives me an X-intercept of 2. To find the Y-intercept, cover up the X, but remember we don't cover up the minus sign here. And divide both sides by -2 to get the Y by itself. So that gives me -3. Now I need to ask myself, do I connect these with a solid or dashed line? Here it's a greater than symbol, so the points are not included that are on the line. So my answer would look something like this. My graph would look something like this. But remember, we always need to shade for inequalities. When we graph them on a coordinate plane here, there's always going to be a region that's shaded. If I stopped here, I would lose a point because I'm not finishing out my graph. Because there's other points that are going to be included here, because obviously the ones on the line are not included, so we have to figure out what points are either above or below this line. So let's put 0, 0 in here for X and Y. So now I have, so let's see if this point, because we pick a point, it's always important to pick a point that's not on the line. Okay, so 0, 0 would be where X is 0. I want to see if this is greater than 6. Well, 3 times 0 is 0. 0 minus 2 times 0 is 0. So I have 0 on the left. Is that greater than 6? No, it's not greater than 6. So I'm going to shade below the line. So this is what I was talking about earlier. If I have an equation that's greater than, it does not always mean I shade above the line, because here's one where I shaded below the line. Let's look at this one here. So here I graph the X and Y intercepts. Actually, why don't you guys try this one on your own now? We've had a practice with a few graphs. So why don't you try graphing this one on your own? And so pause the video and hit play when you're ready to check your answer. Okay, so you should have started this one out again using your X and Y intercepts. So now for this one, when we find our X-intercept and we cover up the Y, we get an X-intercept of 2. Now notice how when we divide both sides by 3 to find the Y-intercept, you're going to get a decimal. And when you do that, you get a decimal of 2 2/3 or 2.67. So my Y-intercept, I'm going to estimate. Here's 2, so 2.5 would be here, so 2.67. Let's say is approximately there. Again, we use a dashed line. Now to figure out if it's above or below the line here, I'm going to use a point 0, 0. see if that's a true statement. 4 times 0 is 0, 3 times 0 is 0, and here I get 0 is less than 8. That is a true statement. So that means that I am going to shade the region that includes that point, that includes the point 0, 0. Okay. Okay, so let's actually stop this video here at this point. We're going to talk about the second half of the notes on the next video. But so just to summarize what we did here, you want to make sure anytime we go to graph an inequality that you always shade a region. If you forget to shade the region, you're going to lose points. And also, not only is it important to have the line in the right spot, but to make sure you're using the right kind of line, whether it should be a solid line or a dashed line. So on your test, it'll be worth a point or two for having the graph in the right spot. Then it'll be worth a point for using the correct type of line, whether solid or dashed. It'll also be worth a point for having the correct region shaded in. So if you do everything correct, or if you graph the line correctly but you use the wrong type of line and don't shade, you're going to lose half the points. So it's a crucial part, the rest of this that we learned today, about the type of line to use and where to shade. So like I said, we're going to stop this video here because I'm limited to 15 minutes. So we'll stop the video, and part 2 we'll talk about lattice points.